Hey everyone, in this video we are going to see what is Prometheus and why is it so well known monitoring and analysis tool in CNCF ecosystem. If you are new to this channel, I am Kavile Koparkar. I make content around open source, DevOps, DevRel. So let's get started. So before even moving into understanding Prometheus, let's take a quick scenario to understand why Prometheus comes into picture when you are working with servers and clusters. So for this tutorial, you also need to understand what is Kubernetes and should have a basic understanding of how you deploy and stuff. So if you are new to Kubernetes in general, so please check out the video into the description. I have already created videos on Kubernetes, Kyverno, and other tools related to CNCF ecosystem that will help you understand Prometheus better. So let's say you have multiple services running on different servers. So server 1, server 2, maybe in server 3. There are multiple services and pod runnings on it. Cool. And these pods are communicating with each other in order to show your application. So let's take this as a web app. Sorry for the drawing. So let's say this is your website, etc. Cool. And what happens is that this server or this cluster runs out of memory. So this pod is directly linked with this pod in this server, which has database, which has your databases where all the information is saved generally, right? And now what happens is, due to this server going down because of memory, now these database are not able to work. And now, as the databases are linked to your authentication service, so authentication service which is linked to your application, now your authentication service fails and now you are not able to log in and use your application anymore. So you can see that the server which is not directly linked, so you cannot in general sense, what we do is, if something fails, we go back and try to trace out where it is failing, right? General debugging scenario in any programming language and any project. So but what if you have like a distributed pods and services running in different clusters and servers communicating to each other, and because one is failing, it uh, it makes other service or other pods fail and eventually creates this long chain where it's failing. So but in this scenario it's really easy. You can directly go back to auth is failing. Is database failed? Yeah, databases are failed. Why is database failed? Then you get to come here, right? This is simple scenario. But what if there were, let's say, suppose hundreds of services and pods interlinked? Like, they can be interlinked like anything. They can be interlinked like this. There can be multiple servers, pods, etc., and it can be a very complex mesh, see, it can be like this as well. So say suppose it's linked super complex, and how do you navigate where it's failing? So this becomes really tedious job and really frustrating job to check on them manually and figure out what's wrong. So that's where Prometheus comes into picture. The main advantage Prometheus provides is you can actually see and observe what's going on inside your cluster and servers, and whatever is happening inside your application architecture and infrastructure. So that's where Prometheus comes into picture. And not only when the problem has occurred, but you can actually understand. See, here, the say suppose memory limit was 100 MB, and 100 like the application went to 102 MB, and now that's failed. But what if I was able to say suppose I'm Prometheus and I was able to alert you on 80 MBs that your this server has reached to 80 MB, and if you don't take care of it right now, it will eventually fail. So I get the alerts and stuff beforehand, before even disaster or the application goes down, that there will be a time where the application may go down and I need to look into it. So this is where Prometheus is packs it so interestingly, that it observes each and every service, each and every target. We will see what target and metrics and everything like ahead, but it observes everything in your cluster, in your servers, in your infrastructure, and according to the rules given by you, it is able to alert you and tell you where it's failing, give you maybe uh, warnings and best practices suggestions and something like that. So that's how, and that's why we need Prometheus whenever we are working with our infrastructure. So now we know why we need Prometheus. Let's go ahead and see how Prometheus actually works and is able to do all these things. Okay, so if you have already seen my Kyverno video, if you have not, please do check the link in the description or somewhere around up here. So you might know that Kyverno is installed inside the cluster into its separate namespace, and the same is true for Prometheus. Usually, what we do is, so this is a cluster, and there is a default namespace. Generally, we I use, like for demo purpose, we use default namespace, and here your pods and stuff are running. So what we do is we generally create a separate namespace called monitoring. So here your Prometheus, all the operators and everything is installed, and then it is able to keep track and look for like whatever your alerts and stuff, it is able to work because it is inside a namespace in the cluster. So that's where we position our Prometheus in general, and you need to know that. Now, what is target? So we have seen it. So there are some terms you should be knowing about when you're working with Prometheus. First is target, and second is matrices. Matrices is pretty obvious because Prometheus is known for generating metrics and analysis. So for let's see what is target. So target is anything that a Prometheus is observing. So that can be service, that can be let me change the color, that can be service, that can be database, that can be pods, servers, anything. So whatever Prometheus is monitoring and observing, that is known as target. And targets have unit for metrics. So target for, say suppose, so targets have units for generating matrices. So for example, say suppose servers might have units for like CPU usage, memory, and like as we discussed earlier, memory and stuff. So all these are called as units. There are many more for each, but in general these are called targets, whatever Prometheus is observing, and on what basis it's generating the metrics is known as units. So these are units. Yep. So what are matrices? So for matrices, there are three terms you need to know, like the types of matrices. So this is counter. One is counter. Another is gauge, and third one is histogram. So what is counter? It is super simple, as the name suggests. That counter, it counts how many time this request is like how many times it runs, right? So that's what this counter metrics generate. uh, then comes gauge. Gauge keeps track of what the current value is. So current value, so like you know, don't need to like remember this, but it's good to know about them. So that's why I'm mentioning them here, and it's good when you like look into metrics and stuff, you know, like what everything is doing and what each metrics is known as or called as, right? And histogram, so it will keep track of how long and how big the size of the request was, and like you know how the histograms are formed, right? Something like that. So yeah, that is what histogram is meant. Now that we know of these basic features and stuff for Prometheus, let's go ahead and see what a Prometheus server is made up of and how it collects and shows all these matrices and how it is able to work. So Now that we have seen basic information and terminologies in Prometheus, let's go ahead and see how the Prometheus server looks and how it functions. So let's create a simple server kind of architecture. And there are only three main components of this server which you need to know to understand Prometheus to its best. So the first component is oops the first component is retrieval. You might be able to understand from the name. If not, I will surely explain it in a bit. Then there is time series database, and there is http server. http server. Cool. So these are the only three components you need to understand in order to get full picture of what is Prometheus and how it works. So this is image, and retrieval is connected with this, http server is connected with this, and this is database, and it actually stores everything into your hard hard disk and stuff. So HDD or SSD, whatever it is, it saves in. So it's like the physical memory. It's physical memory. Cool. So these are the three main components, and that's all you need to know. So what is retrieval? Basic. First, picture it in the same way that Prometheus pulls the information of pod service and whatever target we are planning to monitor. It pulls it, it saves it into a database, and with the help of HTTP server, which kind of provides API endpoints, it connects with it, and now you are able to get this database data into whatever you want to display. So let's see what like whatever I'm trying to say is, like, say suppose this is target 1, target 2, target 3, and these are all the targets, right? And now actually there are like few more components here, like there is a push gateway. So don't need to remember it like super concretely, but vague in, like, just try to think of it in the form of picture and how I'm trying to show it to you. So when, like, this is the target and it pushes its data to this push gateway, it pushes its data here, and now retrieval, this, let's change the color, it pulls the data and it's into the retrieval. So retrieval pulled the data, then it stored it inside the time series database. So time series database is, like, if you don't know, you can obviously go on Google and search and learn more about what is time series database, but in general it's a database like where data is saved with relation to the time. So that's why it's known as time series database. So this is where the data is saved on, like, physical memory, as I told you. And now whenever you go to HTTPS server, like, it provides the endpoints. So generally it's metrics, something like that. So whenever you go to, like, say suppose API endpoint is there, so API metrics, then it goes to the HTTP server and it goes to time series database and pulls the data for you. So you understand now how this is working. So when you know how it's super simple. It pulls the data, whatever you're trying to see, it stores it somewhere, and now whenever you need it, you go to HTTPS server, and now you are able to pull the data and show it anywhere, or just use it as a data or anything, however you want. So now there is, like, a bit more features added to Prometheus. So it doesn't just stop here. It, like, it's not super complicated next. So if you just see it into interesting manner, so say suppose now I want to show it into UI, or like graphic UI. There is like metrics, graphs, the waves and stuff. So I have UI, I can, like, if I have UI, I just connect my HTTPS server to it, as we, like, give API calls and stuff, and you will be able to show the data here. If you have, like, Slack or maybe a website or another metrics dashboard, anything. So say suppose you have email, everyone has their emails, I say suppose, and there is Slack channel, then there may be a Discord, something like that, right? And what if I want, if the memory of any target is going to fill up, say suppose as we took previous example of 80 MBs. So say suppose a memory limit comes to the 80, remind me or notify me on my Slack. So what you can do is you can connect your Slack to. So now this comes in alert management. So whenever alerts are generated, you can actually point the alert managers to the, like, whatever channel you want, and you can uh, give alerts or show it in the form of UI. And there are multiple UI so Prometheus, and you might have heard about Grafana, and in this tutorial we are going to see the Grafana, but there are many. You can build your own dashboard as well. Prometheus has its own dashboard. Then like Lens, we have seen Lens in our one of the previous videos, so check it out if you haven't already. So you can actually see the metrics data on Lens as well. So this is UI. You can build your own, and there are multiple pre-built UIs and stuff. You just have to connect to HTTPS server, and you can do that, or just go to this metric URL, and you will be able to fetch all the data. So that's all is there to the Prometheus server. So this is the Prometheus server in general, Prometheus server. And if you want to understand more of this architecture, I have already written a detailed blog on it. So if you go, the link will be in the description. If you go to this blog, I have, like, whatever I have explained till now, I have like written it already, so you can refer it as a part of notes. Or if you want notes, I have launched my own notes as well. Everything is free, nothing nowhere you have to pay. So you can go to cloud native and actually go to Prometheus, and you will actually able to see the notes and stuff, resources, commands, not only cloud native, but for open source, my templates, my actions, my and like security files, and everything, every file I use, like, and more notes. I'm preparing for certain certifications as well, so that would come here as well. So that's all. You can actually access these notes for free on notes.kaviliakoperkar.com. The link will be in description as always. So yeah, this is the blog, and let's go ahead to the demo. Okay, so we are in our VS Code and my Minikube. I have started Minikube. We are going to do this demo on Minikube. So you see my Minikube is running, and if you want to access these files and stuff, then you can actually go ahead here on GitHub. Everything is there. So Kavile Koperkar slash practical DevOps. So if you go here, you can go ahead into Prometheus, and the files which we are using right now, you can find them here. So let's go ahead and do that. So now we are here, and see, there is a readme here. So we are going to all the commands and stuff we are going to see. So we have to create a namespace first. As I mentioned during explaining, we create like a monitoring namespace in general. So let's go ahead and do that. First of all, let's check if we have whatever namespace we have. So these are the default namespace and stuff we have by default obviously. So let's create a namespace. So I am writing, I have aliases set up. So k means kubectl. Just there are like on my resources and stuff there, I have like mentioned it in full, but like here I'm just doing it in like alias form. So create namespace monitoring and hit enter, and namespace is created. So k get a namespace, and now we can see the monitoring namespace here. I'll just close this. Okay, we can see the monitoring namespace here. Cool. Now what we have to do next is we have to add Prometheus operator using Helm. So Prometheus, we have to add it to our Helms. So if you don't know about Helm, the video should be up on the channel by the time this video is out. So please do make sure you check Helm, that video out, in order to understand what is Helm and what we are doing here. So it already exists. If you haven't worked with Prometheus before, then most probably it will like take some time and install, but I have already worked with it, so it's already there. So let's go ahead and add another command here. Yep, it will take some time. Yep, it's done, and let's go ahead and now install operator in our monitoring namespace. So if you have given a different namespace while doing this demo, make sure you add like the specific namespace name here after like /n monitoring, uh, and now we are installing Prometheus operator in our Kubernetes cluster. Okay, so our Prometheus, see, it's installed, and now we can actually see them. So let's go ahead. So the Prometheus, it's last deployed and stuff. So let's clear it and get namespace. The monitoring is there, so get all -n monitoring, and you can see everything. So services are running, pods are running, Prometheus pods. These pods are obviously responsible for collecting data and providing all the functionalities which we discussed. See, here is Prometheus operator and service Grafana. So you need to remember this. So see, uh, with by default it gives you a UI dashboard which we talked about, and we will see in like in this tutorial itself we will see how it looks on Grafana. So here is Grafana, and yeah, all the other things. So let's go ahead and deploy a simple Nginx application onto the server to see how we are able to see the metrics. So this is just a simple Nginx application. The same code is copied from the Kubernetes documentation. So if you go to Kubernetes documentation and search for Nginx or deployment, you will get this example deployment file. So it's the same. So now we will go ahead and like I will just go to Prometheus and like, yep. So apply deploy.yaml, nginx deployment is created, and this would be in default. So yep, see, this is in default namespace. We are able to get this. Now what we have to do is we saw, so get services into the monitoring. Let's go ahead and see. So we saw Grafana, right? So here is Grafana. This is Grafana, and see where it is on port 80. So we will just port forward it so we can access it outside the pod and cluster. So if you don't know what I'm talking about, that's why I told you should be knowing Kubernetes and networking into Kubernetes. It's already into the video. So we will just port forward this so we can actually access the Grafana dashboard outside. Let's go ahead and do that. So for that we will do kubectl port forward. I have already see kubectl port forward services / Prometheus Grafana, that's the name. We will do to 3000. You want, you can change it to 8080, 5050, 5000, anything you want, to 80 because we saw it was on 80, and from monitoring namespace. Let's do that. It has started forwarding. I will just create next terminal because we should not like cancel here because it's a running service. We will just create another terminal here to do further commands and stuff. Let's go ahead on our browser and go to the localhost localhost 3000 to access the dashboard. So here we are. So the email or username by default would be admin. So let me just zoom it for you. So it will be by default admin, and password is, if I'm not wrong, it's prom dash operator. So let's show this. So this is the password by default, and you can actually go ahead and find the password from the secrets and stuff, but this is generally the same password for Grafana. Then we'll go ahead and log in. Not now. See, now this is the Grafana dashboard, but you are not like, what is this? I don't understand anything. So it's a UI to display all your Prometheus data and stuff into graphical format. So let's go ahead and just try to explore this thing. So dashboards, let's go ahead and like go to home. This is home. Okay, Let's go ahead to dashboard, browse. Okay, we are able to see this now. And let's go ahead into, say, suppose pods. See, CPU usage no data right now. Okay, no problem with that. If we go to and these are the pods there again. uh, then alert manager, let's see what's there in alert manager. Okay, so see push or notifications, you can actually see a small graph getting here. This is like received, valid, the alert receive rate, and other things. Telegram, see WeChat, Slack, you can actually Slack notification, you can see how like the percentage and all the metrics of like the notifications sent to Slack, the webhooks, WeChat, Telegram, and other all emails, right? See pager duty is also there. Okay, so we are on our lens and you can actually see the mini cube here, and it's connecting. Let's wait for it. Okay, now it's done, and you can actually see it gave me one warning, right? And you see here you can actually see the data, the CPU usage, see limits. I will just zoom it for you if that works here, but I don't think I can zoom. So never mind. So CPU, you can actually see the usage here, the request limits and stuff, memory, pods. See the like CPU usage right now. If you go to memory, you can actually see how much memory it is consuming with reference to the time. So that's why time series database you might understand now, and all the other. I don't think here the CPU. So if you go here, see for each node we are able to see this is the requests and usage. See memory, you can see disk, pods. So this is pods. So you are now able to understand, say suppose there are thousands of services, thousands of pods and everything running into a cluster. Now you are able to figure it out and put it into a sensible data and information, and maybe keep it running and get alerts beforehand if there is a service or a server that is most probably going to go down because of, like, say suppose memory utilization, CPU utilization, maybe cost and something. You can figure that out. So that's all is to it for Prometheus. And yeah, you can actually, if you want, you can actually go ahead to uh, Grafana, and you can actually, there is an option to create your own dashboard. See, you can actually create your own dashboard. Why own dashboard? Say suppose there is, you can customize your own dashboard to what you want to see. So Grafana here shows all the different things and stuff, right? But there might be some things that you don't really need to know, that are okay as it is, but there are some things you need to like keep your eye on constantly. So you can build your own dashboard in Grafana, and like create it as puzzles and kind of thing, and focus on things you want to see from on the cluster and your application infrastructure. And that's it for the Prometheus. It's not super hard. If you just give like follow along with this video and do the tutorial and stuff and try around here and there, you will be able to totally understand what Prometheus is and use it into your next projects and deployments. I hope you understand, and that is all for this video. Please make sure you check out all the links in the description. Share about this on social, and we will see you in the next one. Bye.